Well, my name is John Morrey. It's a privilege to be with you here today. This will be kind of a different presentation than you've probably been having so far, but hopefully it's fun for you. I recognize, of course, I'm between you and lunch, so I'll do the best I can. So a little bit about my background. I've been at FamilySearch for about 14 years. Prior to that, I worked in e-commerce, worked for backcountry.com here in Utah and Amazon in Seattle long ago, back in the days when Jeff Bezos would show up at a meeting unannounced. So that's how long it's been. And so most recently in my career, my background's computer science. I was a developer, programmer, development manager. And during the last several years, I've led what we call our research team, our advanced technology research team, which is really an applied research team in engineering terms. And I'll explain a little bit about that today as I go through the presentation. The last year, so about 2 years ago, year and a half ago, I transitioned to a new role at FamilySearch where I was working specifically on developer productivity around AI and helping to get AI into our workflow overall in our systems. And then most recently, the last month or so, I've been switching roles once again into a product management role, which is more about, at FamilySearch, is about defining what we build versus how we build it. And I'm still very much involved in AI. So FamilySearch is, as far as technology companies go, not very many technology companies can say they were founded in 1894. And I use that term deliberately, technology company, even though, of course, this was long before computers. This was by the way, this was the version of the family history library that you see today. This was it in 1894. It was just the attic of a small house here on close to the Salt Lake Temple. And I say technology has been we're a technology company, and going way back to about the 1930s is when digital filming or microfilming started for going into archives and microfilming these books and records. And also on the preservation side, many of you are probably familiar that FamilySearch has also been a leader in the preservation space. I hate to spoil the fun behind this. This is the vaults the famous vaults in Little Cottonwood Canyon that are put right into the granite rock. This is what's in the vaults. It's not as fun as you might think. It's a bunch of microfilm. So, but this is really, to the point of technology though, microfilming was high tech in the 1930s. Post-World War II, that really picked up for FamilySearch, and it continued all the way through the 2000s, at which point we switched over to more of a digital capture, but that's still going on today. So speaking specifically about AI or machine learning, ML, our timeline also goes back further than you would think. Our first neural network at FamilySearch, believe it or not, was in 2003 in a production system. We also did what we call our match classifier. I'm going to fly through these here because this is from another presentation I gave. And more to the point of the presentation today, I'll be talking about our efforts around natural language processing of records and handwriting recognition or automated transcription. I put these two together. This is about the time I started on our research team, managing this team. And I put these two together because they do go hand in hand. So the handwriting recognition of historical records, but then understanding those records so that we can actually interpret them in a genealogical sense. And I really think you could kind of classify what's going on today as our large language model era. And I'm sure many of you with your organizations are experiencing something similar where there's really been this breakout of AI. Before, it was kind of isolated within my team and maybe another couple other teams within FamilySearch, but now this is pretty ubiquitous thanks to large language models. So I want to talk about a minute why this matters to us on the topic of handwriting recognition specifically. This was my great-grandfather's family tree about 12 years ago. And so he died in 1956. He was an immigrant from Germany, from the Rhineland region of Germany. And we knew who his parents were, but we didn't, on his father's side, we didn't know who his mother was, or his mother's parents. And of course, anyone that knew Susanna Nizas is long since gone. She died in 1889. So the only recourse you really have at that point are going to be records. I wonder if my animations are going to work here. Huh. Does the clicker actually advance the animations? Do you know?
Sure. I think it does. It's just sensitive. You have to kind of hold it closer to the computer.
Oh, I see. Okay. So the breakthrough for me was in this very library down on the third basement floor. On microfilm, I found this record. This is a marriage record in Latin from Germany in 1875. And that's not the button I wanted. There we go. And that's it. Any questions? So in this record, the key here was it mentioned Susanna Nizas. This is her marriage record to John Baptist Burgum. But more importantly, it mentioned her parents, Peter Nizas and Elizabeth Goebel. And so using that information, I was able then to fill in the rest of that family tree. So using that record and others, I was able to fill in that side of the tree. So that's why records are important to us. Beyond that, there's kind of a cool story behind this. This is my mom, and this is her third cousin, Mariana, from Germany. Because we were able to work our way up the tree, we could also work our way down and reconnect with cousins in Germany. And we've actually become, honestly, really good friends. Mariana's daughter, who's my fourth cousin, and her husband, we've become good friends. Our kids go back and forth. Their daughter just stayed with us for 6 months, and we go on vacations together. All of that, again, due to a record. That's why that was important to me. You'll hear me talk about indexing. Indexing is simply taking a record, a historical record, and turning it into a structured format that we can search on and that people can use to find their ancestors. And also, when it's structured, this is my dad's dad, on the other side of the family. When it's structured, this enables something that we call record hints that allow people to build the tree. So I mentioned in 2014, we started with Born Digital text. So this is a digital obituary. We didn't have to OCR it. And we wanted to turn this into an index. So this is a developer view. Don't get hung up on this. But the process really was, when we talk about natural language processing, was identifying or classifying all the words as what type of entity they are, like a name, date, or place. And then also figuring out the relationships, kind of the graphical relationship between these entities, which then can be collapsed down into what we see as an index. And this is what the users see today. So just a comparison, we've done indexing with people through the years, and that people have done a wonderful job. We've had a huge group of volunteers that have indexed literally millions of records. However, first of all, they're not perfect at it. You can think of F-score as kind of like an accuracy score. We did some studies of our human indexers, and even they're not perfect, so there's a little bit of error there. And most importantly, they can't, because you're constrained by people's time, we can't index everything that's on every image. And it's, of course, limited by the number of volunteers. So when we first launched this NLP-based system that I just showed you, first of all, right out of the gates, we knew that the accuracy was going to be a bit lower, and it was. We've since improved it, but it's still probably a little bit on average than a person. However, we also got additional fields at no extra cost because we're picking up like occupation and other things that we typically wouldn't index. The capacity now becomes limited by our budget. And the infrastructure budget for this was pretty minimal, actually. But you think about the budget, the engineering investment was quite high initially. But this is the real kicker. It took 10 hours for this system to index 5.5 million obituaries on one machine. If you were to have one volunteer do that at 40 hours a week, that would be, I estimate, about 360 years to do that much work. So this is like a pretty clear-cut case where it was worth the investment. So I want to talk about and switch gears and talk about, well, that's text that's not born digital, which is the majority of what we have. And so we've got documents, I think by the last count I had, it was about 227 different languages officially. Unofficially, we've got way more than that probably in our holdings. This is an example, I think, of a Spanish baptism registry. And some of these records they're kind of things I don't really know what that is. You know, I look at it and it looks like it to be a passport, but not any kind of passport I recognize. We've got stuff that's also not just, you know, it's got different orientation on it. Other languages, hand-drawn tables, and mixed languages too. This one's actually got Russian and, anyone know what this language is here?
That's not Persian. Farsi?
You're all wrong. It's Arabic script actually, but this is Ottoman Turkish is a language, which is a dead language. And we've got millions of records in Ottoman Turkish. In fact, overall, we've got current count about 5.7 billion with a B record images. Many of them are 2 per page. Just to give you the scale on that, if you were to print those off on copy paper and stack them on your desk, it would be about 350 miles high, which is above the orbit of the International Space Station. What's that? Half that, then, you know, yeah. You're still out in, you know, outer space. What's that? Okay, you guys, I can tell, are engineers. And if you did this as one person, again, that same type of calculation, to transcribe these documents, you know, word for word, you're looking at about 1.4 million years. So thank you, AI, for that picture. So that's the scale of the problem. And really, it's not so much the volume, it's the diversity of the content we had that was the real problem. And so our research goal on the team was, we called it our 80-80 objective, which we were trying to be realistic. We're not going to get everything. So we set our sights at getting at least 80% of the genealogical fields from at least 80% of our holdings. That doesn't sound very ambitious, but when you consider the diversity of the holdings, it actually really has been. And there was a third 80 in there, which was at less than 80 cents per 1,000 images was our target. A lot of people have asked over the years, why did we build our own handwriting recognition and NLP system? First of all, we didn't really build our own in that in the machine learning space, a lot of this stuff, it's very democratized, refreshingly. So in that a lot of the research that's out there is published, there are libraries. In fact, I'll pick on OpenAI for a minute. They didn't invent transformers that they built GPT on, Google did. So, and Google was nice enough to open up that information. OpenAI took it and monetized it and kind of beat Google to its own game. But that's the world for AI, is it's very transparent. And so most of the systems that we built, it's using code that was already out there. The real trick, though, or the real key to this was the data. And this is one of the takeaways for machine learning or AI projects. When you want something to run on your data, the best data you can train it on is your data. And as you see, we've got a lot of data to train it on. So that's why we built our own. I'm going to fly through this because I want to make sure there's time for questions. But this was just kind of the overall architecture or flow of the handwriting recognition system. Is you take an image, you can't just recognize the handwriting. You got to segment it first, both at the page, region level. Then you need to turn things into lines. This, by the way, is very similar to speech recognition. In fact, that served as inspiration. The lead principal researcher on this had most of his career at the National Security Agency doing voice recognition. That's declassified, I can say that. Won't get him in trouble, but he used that as inspiration for doing handwriting recognition because it's very similar in that you're trying to take this digital signal and turn it into text. And just like in speech, words slam together, when we talk over each other, you know, speech is not like OCR. OCR is a different problem, really, than handwriting and speech recognition. So we use that as inspiration, and it worked. So basically, the way this works is we then send that, we turn that into a digital signal, send it through what we call the optical recognizer, and you really get back a list of probabilities for every character at every position of a clock, basically. And then we have a language model that resolves that into the actual text. Probably more technical detail than you wanted, and I'm definitely going to skip over this. That other than saying just the line segmentation part is probably the most complex part of the engine, believe it or not. When I talk about segmentation, this is what I mean. A document like this, you've literally got to go through and find every single handwriting snippet in that and separate it out at the line level to do recognition, which we did. Here's some other examples here. And so then at that point, it's now ready to go through the recognition. I'm not going to, don't worry, I'm not going to get into the details here. Just suffice it to say that it is a deep learning-based recognizer, which we trained on our own. The language modeling, this part was novel. We actually did, this was a little more than applied research. Our researcher did some more basic research to figure out how do we pair this thing with what's called a finite state transducer. I won't get into that. The overall architecture then is that the kind of the flow of this is that we would send images through our line segmenter. We had actually 30 different models. We've got more now, depending on the language that we had to train. This is just to give you an idea of the complexity of the project, really. We actually had 30 different language models as well, and then we sent it through a single named entity recognizer, which figured out what the words were, and then several different relation extractors, and then this was just code to figure out how you take that knowledge graph and turn it into an index. Boring stuff, I know. One of the things that came out of this, though, and I promise this will get more interesting at this point, was that we realized we actually didn't need to go all the way to an index. When you do a full text transcript, that on its own is useful to search. And so we created kind of this little outlet here, which we called full text transcript search. And I wanted to demo that. So far to date, out of those 5.7 billion images, we've processed 2.5 billion of our images this way. We got a full text transcript of it. And if you create a FamilySearch account, you can search those 2.5 billion images. So in this one, this was a little demo I did last night. I logged in, I went to full text. And I have an ancestor named Henry Morrey, who's my 8th great-grandfather that lived in the 1600s in Cheshire County, England. So I just put this in there. By the way, I think I'm going to lose a lot of you at this point, and that's okay, because you're probably going to go off and do this, which you can do. So immediately, I don't know if you saw that, but I found a result for him. And I'll zoom in here. Just to give you an idea of the difficulty of the handwriting it's reading. That says Henry Morrey. That's him. I happen to know that's him because of the context of the record. He was a Quaker. He was one of the first 2 Quakers in Cheshire County, in fact. And this is a Quaker. These are minutes from Quaker meetings. And I did kind of going too fast here. Let me go back. I did an AI summary there of that document, and it told me what it was. And I should not have touched that button. Yeah, so there's this little, speaking of large language models, we got this little feature which is summarize the document, which will take all that text and actually tell you what you're dealing with. It says this Quaker Men's monthly meeting record was taken from Nantwich Region Records, blah, blah, blah. So I went down the rabbit hole last night just doing this because there were so many records I hadn't seen. In fact, I found this one, which is a court record. And there's my ancestor again, Henry Morrey. This is actually a summons for him to show up for an arraignment. He was quite a rebel rouser. Actually, the Quakers at this time, a little bit of an aside, the Quakers were, it was a new Christian religion in England in the 1600s. And that didn't go over well. You know, you're talking about, you're not that far removed from Henry V and all that, and the Reformation that happened there. So they were persecuted quite a bit. He was in and out of prison several times for being a Quaker. But I found that last night, just using full text search. I'd never seen this before. So try that out if you get a chance. A question we got a lot about this: how much data was required? This is one example. I like to color code the different line segments because a person went through and they drew a polygon around every single one of those things in that document. This is one image. And then they transcribed every single one of these. And then we QA'd that transcript to make sure it was correct. That's how we trained our handwriting recognition engine. And just between us, we did this about 40,000 times across many different languages. That was a huge investment. So one of the ideas that one of our engineers had throughout this is, how could we use our millions of already human indexed records to train handwriting recognition? The problem with those records is that they weren't created for transcription. As I mentioned, our human volunteers don't index everything. Well, this was before GPT went live through OpenAI. He trained a transformer, what's called a SWIN, which is an image transformer, to take an image as an input and produce an index as the output. This is in Hungarian, and we did not have Hungarian handwriting recognition models. I know this looks like a lot of text here, but basically this is a structured record that was 97.6% accurate, which is very high as far as those things go in word accuracy, on Hungarian, that we had never built handwriting recognition models for. He trained this from about 3.2 million human indexed records. We called this thing image to summary. For reasons I won't get into, we've kind of tabled that for now because large language models are kind of overtaking this. So I want to talk about, switch gears. How are we doing on time, by the way? Okay, half hour, so I'll make sure I leave time for questions. I want to talk about the role of AI today and moving forward, because I think this is probably a question that's of interest to many of you, particularly in the development side of things and the productivity part of this. Do you use AI coding? Do you trust it? Do you use it for code reviews only? Blah, blah, blah. There's a lot of issues here. And this is what I've been doing the last year and a half. I will say, though, it's not just developer productivity. So our tool of choice has been Claude Code. Does anyone use Claude Code here? Do you like it? I found to be, at least as of 6 months ago, is pretty much hands down the best tool. Probably the most expensive too, but this best is being the smartest coding tool. And that's a very rapidly developing space. But we've generally rolled out Claude Code, not just for our engineers, but also our product managers, UX designers, and others in the business. So this is I just want to give you a taste of what productivity looks like here for non-developers. I'm a developer and I use it for development, but this is a case where I used Claude Code to review this presentation that you're seeing today. In fact, I've created an agent, I won't get into this, but an agent that's called Morrey agent that has access to all of my email, every Confluence post I've made, every other presentation I've given. I index that with AI into something called a RAG, Retrieval Augmented Generation database, and created an agent that Claude Code is talking to that kind of represents my knowledge. I know this is crazy, right? This sounds like something, I never thought I'd be giving this presentation 5 years ago. It sounds like something out of Star Trek. but this agent represents my documented knowledge from FamilySearch. By the way, I originally thought I can do this and have this thing represent me in meetings and stuff. Bad idea, okay? Just so I'll say that out of hand. What did surprise me though is how much it's been useful to me to query my own knowledge, you know, emails and things I've written and said through the last 14 years. So I said, I want you to use that agent to critique this presentation that you're seeing. And it said, here's the critique informed by J. Morrey's agent context. It said, audience alignment, the core problem. This is amazing that it picked up on this. He said, this is the most significant issue. It said, most significant issue. The organizers explicitly stated the audience is MediaWiki developers who want to learn about FamilySearch's AI and HWR work. It says it delivers the FamilySearch AI story. This was a previous version of this. But it said, per the invitation email from Darius, he said, John, you missed the point. He wanted to see what you had previously demoed about Wikidata integration, which you guys haven't seen yet, but it reminded me, it was like me reminding me that I missed something in my presentation. This is just like mind-blowing. The reason I share this with you is I think the way we do business is going to change. We're kind of in this, we're all enamored with AI or disenchanted with it, depending on where you're at. But I think we're going to see things start to kind of go a certain direction in terms of communication. I don't know what implications that has for platforms like MediaWiki and the knowledge bases that are built on top of it, but it certainly has some role. That's something to ponder, is how can you then use that content to drive the behavior of agents that may be representing ideas, people, concepts within an organization. Okay, so this, back to the criticism it had, is that I said I was missing a big part of this that Darius had asked for. And so what I want to do is talk, hopefully this will make sense. I'm going to frame it as where we're going in the future, but also partly the role of structured information, which I view as very relevant to MediaWiki and the related platforms. So one of the things that with large language models that I've seen this common misconception with problems like ours and others is that we're so amazed with large language models, what they can do. It's tempting to think that, oh, they're just going to solve everything. And our number one biggest problem is taking this big mass of records that we've got and turning it into a structured family tree. And the answer is no. Large language models physically, the physics don't work for that, for them to do that, the way they work. And the way they do reasoning is not even well understood, actually, but it's certainly not structured, not reproducible. However, I'm not discounting that they're not part of the picture, but on their own, they're not going to turn literally trillions of record references into a big family tree. And this gets, anybody know what this diagram is? I know it's messy. Yeah. It is. Specifically, though, this is Wikidata. This is the Wikidata, which many of you will be familiar with. It's part of the spin-off of Wikipedia, but it's the Wikidata schema or ontology as of like 4 years ago. The reason I put this here was to illustrate a concept that I think is really important. Actually, I'll come back to this in a minute and say why, but let me just show you a little bit what's in Wikidata already. This was, again, several years ago that I did this, but in using the Wikidata query, this is against the Wikidata, again, not against FamilySearch. I was able to query, first of all, who are the ancestors of George Washington? And where did they live? This is all in Wikidata today. I could plot where George Washington's ancestors live. George Washington is the first president of the United States, for anyone that is joining us from elsewhere. I could say, give me the pictures. This is in Wikidata today. And by the way, George Washington, his mother, that's about a 97% match. That's a kind of an inside FamilySearch joke because we have this feature called Compare a Face where you can compare your face to your ancestor. But clearly there's some resemblance there. But I digress. I could plot the descendants of Genghis Khan. Boy, I'm just amazed that this is in wiki data today already. That's a very family tree centered view there. And even a lot of these people in the wiki data have their FamilySearch ID even referenced there. So there's already a link between Wikidata and FamilySearch. So, and I'll come back to that in a minute. Okay, so more to the point and why I care about the Wikidata project. So this guy, John Lathrop, is well known to genealogists because he's what we often call a gateway ancestor. For some reason, everyone in the United States seems to be a descendant of John Lathrop. Who knows why? You know, like he was just, he wasn't that well known, but he was a preacher back in the early days of the United States. And more particularly, a lot of the presidents are descendants of John Lathrop. And also people like Joseph Smith that founded our religion is descendant John Lathrop. Anyway, I digress again. The point is, using the wiki data, I can say, give me the descendants who played professional sports and what team they played for. That data is not in FamilySearch. But that's really interesting to me because we don't think of your sports team as being a genealogical fact. However, when you're stuck on a hard research problem, you take anything you can get. We know that these are what we call genealogical facts. But what about organizations you belong to, like a sports team, business associates, your whereabouts on a given day, or a sports team that you play for? Darius, who's a researcher, can tell you this. You pull on any thread you can when you're blocked, and you may find, you know, like the example of my ancestor, the fact that he was a Quaker was very relevant genealogically because it meant I needed to look over here in the records instead of where I was looking. So what I like about projects like Wikidata is it's more comprehensive. It's still a genealogical database, but it's more than that. And that was, going back to that first diagram, that was the schema, just a small part of the schema for Wikidata. The other reason I love projects like Wikidata too is just the whole concept of graphs. And does anybody not know what a graph is in terms of computer science? So a graph is kind of, you can think of it as a network of related things. Instead of like a classic relational database where you really have what I would call one-hop relationships, like this person is managed by this person in the organization. A graph is a way of conveying those multiple hop relationships in computer science. And you've heard of graph databases. Those have become increasingly popular. The reason graphs are useful is this is a very simple graph I created, fictional. Like pretend this is a social media graph, and I'm showing relationships between people, friends. Those are the ones in red. And let's say that the green arrow meant that they graduated from this high school here. You can use a graph to answer other. Meeting was ended due to inactivity. Oh, that's a different meeting. Okay. There we go. Yeah, that was from my. No, it was. Oh, okay. Yeah, I'm on that laptop. So you could use it to answer the question. Let's say I'm doing a high school reunion for Valley High School. Who should I invite? Clearly, the ones that have an arrow pointing in. But the interesting thing about a graph is you can also do something called link prediction. So potentially, if you look at the relationships here, you can infer that Jerry may have also graduated from Valley High School just because of who he's friends with. And Shirley maybe went to Valley High School too. So this is what we call link prediction. There's also what we call node prediction, where you could potentially infer that another high school exists that you don't know what it's called, but based on a cluster of people that have friendships. This is also how LinkedIn and Facebook give you sometimes some recommendations that just blow your mind, like regarding the fact that maybe Evan and Chuck want to connect because of their other relationships that they have. I thought I moved this slide, so I'll come back to it. Okay, I missed a whole bunch of my presentation here. I thought I had the current copy, and I don't. Oh well, in the interest of time, I'm not going to try to pull it on. Sorry, this was the complexity of switching my presentation to another laptop, as I missed the current presentation I had, and I had a whole bunch of other slides on graphs and graph completion. But the point of this is that FamilySearch really is a graph problem when it comes down to it. It's a node and link prediction. It's okay, Jeff. We'll,
Sure. Okay.
Yeah. Okay. That was my bad. I just got my versions mixed up there. So FamilySearch is really a graph problem. Our objective is to build the tree of humankind. Ultimately, that's what we care about. And that's tied to our religious objectives as well, of course. But we're not really a genealogical company in the sense of like that's a means to the end for us. We want to build that tree. And currently we're investing quite a bit in doing that with AI. And as I mentioned, large language models are not the right construct for that. The problem is that large language models are, well, they're very smart. The reasoning is not structured, and it also isn't good for asking questions like, who is John Morrey's 8th great-grandfather? Because there's not enough text that it's been trained on to know that. It'll make something up, don't get me wrong. It'll make up a great story. But you need to have these structured data sources that it relies on. And the coupling of those two things is where we start to see some real interesting advancements. So we're investing quite a bit actually on building trees automatically from these records, using large language models maybe as localized reasoning. Like if I'm looking at two people and say, are these two people the same or different? We may invoke a large language model to help make that decision. But we recognize that the bigger picture of constructing a graph of potentially 50 billion people out of trillions of records is not a large language model problem. And so I view it as a graph completion, graph reduction challenge. Completion part is like predicting the links and the nodes that need to be there, and the reduction is collapsing the duplication that's going to be there. But we're investing quite a bit right now in this line of research. And it's not as simple as I'm kind of making it out to be. It's not just like predicting links on a social network. The logic behind deciding whether two nodes are the same in a genealogical context is very tricky. It's hard to put into code. And sometimes it requires a very creative researcher to sort these problems out. So this cut my presentation short, which is probably a good thing, so it gives a chance to ask questions. But I'm curious kind of what are your thoughts and what are your questions? Yeah.
So you can do sort of genealogical style queries on Wikidata itself, but are you capable of doing those kinds of queries, blending Wikidata with your data about your people that you have? And if you don't have that, would you like that?
That's a great question. I'm definitely interested in that. You bet. If we can have linkage between FamilySearch personas and Wikidata personas, that would be incredible. In fact, it's already there to some degree, as you see. There's references. The way you do that computationally, I'd love to figure that out, though, because when you're doing, as you probably well know, graphs that are partitioned, you have the problem of crossing the partition too many times, and that can really slow things down. But you bet, I'm definitely interested.
So
yeah.
The thing I find fascinating about using AI for genealogy is that it's probably still really useful if you're only right half the time. To what extent, I guess it's kind of a two-parter, to what extent does human input from people that are just using FamilySearch after the fact, not researchers, but just random people, looking at these records, deciding if they're relevant, to what extent does that inform future training or the design of the tree? And I guess also, how many people are really looking at, let's say, baptism records from the 1600s? How many people are doing what you're doing and finding your 8th great-grandfather currently? And is that sort of a bottleneck in constructing the right tree? Is the lack of humans looking at these things after the fact that are surfaced by the graph creation?
Yeah, so if I can unpack that question and tell me if I get this right, is first of all, are we using the human behavior to train the models? Is that the first part of your question? And let me take that one first, is that we've tried. We haven't been as successful as I would have hoped. So like handwriting recognition was a good example. We've had a feature there for several years which allowed you to correct the handwriting recognition if it was wrong, with the thought that we're going to use this to retrain our models and improve them. And for a long list of reasons, it hasn't been practical. The main reason is that people that aren't paid to transcribe don't transcribe it in the particular way that we want, and that can actually send the model in the wrong direction. For example, they transcribe what it should have said instead of what it does say, and that happens all the time in historical records. The other thing is that the question is, when it comes to machine learning, I think the key challenge is how do you frame the problem? And so when building the family tree, for example, you think that would be an easy problem to frame as a machine learning problem, but it's actually not. When I say frame it, it's like, what are the inputs and what are the outputs of the network? And that we're still trying to wrap our head around it. Once you actually have a conceptual model of the machine learning problem and then start to build the data around it, you're actually 90% of the way there. So we're still kind of noodling on that part. I don't know if that made sense, but that's why we're not using the user data, is we don't really know what that machine looks like yet. In terms of the actual fingerprints on the records, that record I showed you, odds are I'm maybe one of 4 people that's ever looked at that in the last 100 years. That's just, and there's that problem with, and this is again why large language models aren't a great solution. It may have seen that file once in its training of trillions of records, and so it gets washed out in the weights, like it's not part of it. And a lot of what we do is long tail like that in family history. It's important to me, it's not important to you, but the converse is true too. There are records there that no one's looked at that contain your ancestors in it, no doubt. So I don't know if that addressed the question.
So something that happens when people are talking about doing computerized number theory proofs is that something will require so much computation that if you are unable to do part of the computation now and save your progress, the most efficient way to do it is actually to do nothing for the next 10 years, wait for hardware to improve, and then start running it later.
Yeah.
And given that you have like time and budget constraints, I'm wondering if you have if you've encountered that issue with any of the development that you've done over the years, where in maybe 2018 you were like, oh, well, we could run this, but it is so expensive that we're going to wait until 2023 to run it. And if so, like, when did you do that?
That's a very insightful comment because, you know, I mentioned that system at the end where we could train it to run, to index a record straight to the index without going through a transcript. The reason we paused that was this very reason. First of all, we had to buy a very expensive box to train that model. But second of all, it seemed like large language models were on a trajectory. They're too expensive right now, but if we wait, the cost will come down enough that maybe in, say, 5 years, we can run all this stuff and save ourselves the engineering cost of having to build these models. I don't know if that made sense or not, but this happens all the time. And I think a lot of organizations are doing a similar exercise with large language models right now. It's just like, yeah, this is really expensive. It'll do the trick. If I wait, maybe this, and it will. You know, if you follow the trends, eventually it will. One of the challenges, though, is we always want the best model, which is the latest, most expensive one. But when it comes to the tree, though, I definitely think we can save our work as we go along, as we assemble the tree. In fact, that's really what family tree is. It's the view of what our best guess is what the tree looks like with all the sources linked in. That answer the question? Or, yeah, thanks. Great insight.
Hi.
Hi.
Sorry. Hi. So this is fascinating. You keep talking about genealogy as a tree, what happens when it's not a tree? Like, not first cousin, but at some point you're gonna have, 10th cousins 15 times removed
Yeah.
who end up marrying and having kids or
Yeah.
not marrying.
We call it a family bush, not a tree. Yeah.
So how does the fact that it's not necessarily going to be a tree factor into the decisions of what you do in the design of the machine learning, where, if 99.9% of the relationships are going to be a tree, and then you have some that the AI is like, oh no, that's just not going to happen because I'm not trained on it. How do you account for that?
So it always is a tree in the sense that you have two parents biologically. At least that's the case now. I don't know if that's going to be in the future, but like that's the case, is there's always at least a little tree there. The question really is about when it starts to fold back in on itself. In fact, we've done some analysis of our current tree, what it actually looks like. And it looks like a family bush, actually, that comes back around like this. It fans out massively, but then it starts coming back together, and we have these lines that go way back. And part of it's because the records aren't there. It's not just that we're all related, but we are all related multiple different ways. That, in some ways, it doesn't really complicate the problem for us, to be honest, that's the case. In fact, some ways it simplifies it, because you end up getting into a branch and say, oh, I've already done the computation there. Yeah, I've already figured that one out. I don't need to do it again.
Awesome. Thank you so much, John. I've been looking forward to this presentation, and did not disappoint, obviously. So super excited to learn about all these things. I was originally under the impression that this would be a talk about like agentic mode or something, of like being able to ask kind of like a FamilySearch specific ChatGPT to put it to the general audience's understanding. I know that this isn't what was talked about today, and honestly, what was talked about today is way cooler as like a CS geek. But yeah, I'm absolutely curious to see what your
Sorry, I'm listening to you. I just wanted to show you that what you're just talking about.
Yeah, what that looks like for you if you're trying to invest into a chat-based chatbot experience, and yeah, what you guys are going to be focusing on, and all that good stuff.
Actually, sorry, this is not going to work for a quick demo because I don't have my credentials on this machine. But
no worries.
If you go to FamilySearch and sign in, and then go to FamilySearch.com, FamilySearch.org/labs, there is a feature that's the chat bot there that you can actually chat with. Or when you go, and there'll be a feature to enable the experiment that when you're an ancestor. Yeah, you bet. That'd be great. Do you know where the AI research assistant is? Have you used that before?
I know where Labs is.
Okay. So that's there. I'll tell you though, I'm sorry we missed the mark too on the presentation. I should have shown that.
No, not at all, not at all.
But
yeah, that's better.
I'll tell you one of my challenges strategically with that is again, this is the question about do you wait? Because I see events overtaking us there. With platforms like ChatGPT, that becomes the chatbot, where the browser has a chatbot in it.
Did I miss it?
Oh, let's see.
Gotcha.
Yeah, there you go. Yeah,
Cool.
So go to experiment. Now click on anyone in your tree. Why don't you go back a little bit further? Let's see, let's do, yeah, that's great. Yeah, perfect. And then ask AI Research Assistant there in that upper right-hand corner. Is this what you were talking about?
Yeah, stuff like this.
This is one place, so you can actually say something like, ask, oh yeah, there's your questions there that you can ask. What was it like when Hans Christensen was alive? Help me find his parents. Why did it just do that? Oh, okay. No, that's okay.
I can ask it something else.
So, but it actually is doing the more localized reasoning about that ancestor in context there. So the thing I have, though, coming back to the point of my comment, I wonder if events are going to overtake us here, where your browser does this now. Like, can you imagine like being just in your browser and saying, I want to take this record that's on this website and put that in FamilySearch Family Tree for me, and that's it. Or how do I do research for this person? And it knows where all the sources are out on different MediaWiki sites, and it like understands how to do the research, and it does it for you. I think that's coming, and so because of that, I'm a little bit reluctant to overinvest in a feature like this.
That's very forward-thinking, and I agree with that caution. And maybe the next stage is a FamilySearch agent instead that can plug into Claude or
Mhm.
you know. Your
We're
LM
looking at that,
preference.
in fact.
Awesome. Thank you so much.
Am I standing in the way of lunch at this point? Okay, all right.
So thank you. This
Okay,
is
great.
pretty fascinating. Actually, Megan and Jonathan already asked the two-part question I had, but there was one little follow-up that I wasn't sure about. So you talked about the 80-80 kind of rule you're targeting.
Mm-hmm.
For that kind of 2020, is it a silent fail, or do you know that it's missing and you have it kind of flagged for follow-up in the future?
Yeah, there's lots of different ways that we know that there's a failure there. I don't like, personally, I'm kind of a data scientist. I don't like the silent failures, because if they're silent, you don't really have a number on it. So for us to know that we fit 80-80, we had to have a test set that we created. And the way this works, and this is pretty much part and parcel with machine learning, is you take a data set that represents the problem space that you're trying to apply it to. You have people go through and you say, this is what truth is. Like in this case, this is what the transcription should be for this image. But then we hold it out of our training. We actually even hold it out of the developer's view so they don't see the answer key. But then when we run the system, we can score it and say, okay, you missed 20% of these fields. So that's how we score that 20%. But in the bigger picture, it is silent in that I don't know which 20% I missed in the bigger pie that's outside of the truth set, but I can assume it's around 20%. The other way we know where there's a failure is just we already have some metadata on these images to know like what's the language. Like I know I don't have a recognizer for Manchu, which is a historical Chinese language, but yet we've got many images. So I can just, when I see that image out of hand, I can say that's part of the 20%. Does that make sense?
Hello. I assume there's a ton of duplication in your overall graph. That is, the same person shows up in a bunch of different nodes, because there's no way to 100% be confident that it actually is the same person.
Yeah.
What are the mechanisms for merging nodes together, and can AI be involved in that?
Yes, in fact, I mentioned that really briefly the match classifier that we first built in 2010. That was what it was classifying, was given this persona and this persona, what's the likelihood they're the same? And we've continued to invest in that, because that's probably one of the core, that's, I would say the core problem, but essentially that's the core problem, is you got two records. Like one is a birth record and one is a death record. So that's going to bookend somebody's life, but you have to decide, is that the same person across those records first to know the birth and death date? So we put a lot into that problem, actually, and so is the industry. That is sometimes the hardest problem, though. Like my ancestor, one of my ancestors, John Morrey, John John Morrey in England, is married to a woman named Mary Morrey, and they're having kids. He has a second cousin who's also John Morrey, married to a Mary Morrey, living 20 miles away. I'm not making this up. And they had no middle names. Mm-hmm. Yep. They're attending the same little Quaker church, too. And the only reason I know they're two people is that reading through the Quaker records, I can see that they're in the same place at the same time. There's two different Johns. But in the census, we keep or not in the census, but in the other records, we start pulling them together because we think they're the same. So that's a really hard problem. Did I touch the question at all there, or is it, what was the?
Well, I guess whether AI can somehow magically help with that, I suppose, is the
Not magically. I think but it certainly can help. Like all in the training data, but there's a lot of nuance there. That's why just a simple match classifier doesn't always solve the problem, because the nuance, when you think about it, that I've got a Quaker record that shows 2 people named John Morrey at a wedding on the same day. What are the odds that the person taking the notes just forgot that he already wrote down the name versus that there actually are 2 people? That's a very nuanced kind of human intuition thing. And that's really hard to capture. But
Amazing. There are so many areas of this that are fascinating that one could go down a rabbit hole on.
yeah,
It's very cool. In preparation for the conference, since you all very kindly offered to give this genealogical experience to the attendees here, I signed in and I started entering my family tree. And it gave me the option, like I can't remember whether it did father or mother first. And I entered their name and where they were from. And it came up and said, oh, are they any of these people? And it gave like 3 completely unrelated people. And I'm like, okay, that's weird, but no, it's not. Then it did the same thing for my other parent. But then once it did actually have the information for both of them, which it was just a matter of like 10 clicks at most, it found all of my grandparents, their parents, their siblings, their spouses, just like that. So I was sort of curious, like I'm assuming that the unrelated people that it first suggested for my parents, there's some reason, like that's one area that I could go down a rabbit hole. There's some similarity there, some reason that it thought it might. But then it found all of this completely accurate information, except there was a great uncle of mine who it said that he was married to this woman who I'd never heard of before. And I knew he had 2 wives. I didn't know there actually was previously another wife. And I'm like, no, this couldn't possibly be right. It showed me a document that was an account of their wedding that was completely, it was like absolutely obviously. She lived until the 1980s. They got married in the 1930s. So it's just amazing.
do you have any cousins through there? Or?
I don't know. That's the next rabbit hole I need to go down. But because she lived for 50 years after they got married in Italy, whereas he emigrated to the United States just a couple of years without her, a couple of years after the marriage.
You
So
may
there's
have
like
a place
so
to stay when you visit Italy, so you
Yeah,
can
clearly.
research that one. Yeah.
So it's just, I was extremely impressed at how much information with just a few clicks it was able to find with documentation supporting it.
Yeah.
It just
Some of that magic
amazing.
a lot of it comes from the fact that you've got cousins out there that have done that research, that you share some common ancestors.
Yeah.
If you live in the United States, odds are really high that once you put your grandparents in, it's just going to fill things out for you because
and this
someone
could-
else has already done that.
2 generations back, one on my father's side, 1 generation back, they're all in Europe, and yet all that information, it was able to cross the ocean and get it. So very, very cool. Awesome. Do we have any other questions in the room or?
I have one more, if that's okay. I can
Yeah.
also just talk about really quick. So what is the end game here? If you had like $1 trillion to build the tree, you had infinite access to humans, and this was something that everyone collectively around the world had the same level of interest that all of us do here. What's the end game? If we're going to look at the 100 billion people that have ever lived, how far could we really go? Does that get into DNA analysis at that point? Is that a reasonable question to ask?
It is a reasonable question. Our interest obviously is what's the documented horizon, because we can't really go beyond that yet. But there are some theoretical questions about, like I have a good friend she's now a professor of computer science at BYU, but previously she was doing bioinformatics. And I've asked her that question before, is like, could you actually, you won't know their names, but could you create DNA placeholders for people in a tree? And theoretically you could. There are lots, but there has to be sufficient samples and all this stuff that's not going to happen. But our interest is what's documented, that horizon really.
Cool. Thank you.
Yeah, sorry, I think you had your hand up first.
I just had a question because I'm married to an immigrant from Vietnam who does not really know the father side of her family, and you're talking about documented stuff. So what luck have you had with, and you know, she knows some of her family here in the States, but does not know any back in her home, the country that she came from. How does that work with someone doing research like that?
So, first of all, while you're here, I would talk to, I think is it the third basement floor where we have international? There may be somebody that has a little bit of expertise specifically in Vietnam. The unfortunate part about some countries, like Cambodia, I don't know Vietnam, but Cambodia, during the Khmer Rouge, they lost a lot of the records, not to mention a lot of the people that had the memory of who was related to who. And there just really isn't a way to recover that. But what I found is that there's a lot more in people's heads than you may realize. Like if she's able to connect with her family in Vietnam in any way, there may be somebody that knows, oh, great-grandmother was so-and-so. You know, that was passed down through the family. And so in Africa in particular, we've done quite a bit of what we call oral genealogies, where we'll go into like a village and formally interview people that have memorized family history and try to get it documented. But it is a different ballgame, though, when you're going from memory and records that have been destroyed. Some of the same thing, by the way, happened in the American South in Civil War era, where just courthouses were burned and everything's gone.
Right. When we went downstairs to microfiche and stuff, they said that there were some records that you had that had been bombed or whatever, and those were the only records. That was interesting as well. But I don't think they have that same sort of thing for Vietnam.
Yeah, I don't know the specific situation. I know it's pretty sparse for Cambodia, but Vietnam may be a totally different situation.
We have one last question, and then
Okay.
we are going to take a break for lunch.
Awesome.
Let's try and end on a good one. So you talked about just now about trying to get that oral history and things that aren't written down. In Judaism, direct male descendants of Aaron, the brother of Moses, are Cohens, and the rabbinical question can be discussed separately. But if you have people that say, "Oh, I am a Cohen," and thus me and anyone else who says that even if we don't have the written records that go all the way back there, we say that we are direct male descendants. Is that something that you're able to incorporate?
Yeah, interesting that you say that, because the same thing exists in many cultures throughout the world, actually. So in China, for example, historically the genealogies were passed father-son. You did have, it would mention a spouse or a daughter, but it wouldn't follow the lineage deeply. It would just say she married so-and-so in another clan. But you have these father-to-son links that go way back. And sometimes there's gaps too, where you're like, I don't know how I'm a descendant from this guy, but I am a direct descendant. And so we do have a way to represent that in the tree, actually, these kind of skip links that are there. And I have this with some of my Morrey relatives in England too, that we've done a Y-DNA test that shows that we share a patrilineal ancestor. We have the same last name, but we don't know how we're related.
Awesome. Well, thank you very much. This was very interesting, and I appreciate it. And thank you for being here.
Thank you for having me here. And thank you for all that you do. It's a great platform. We've used it at the last 3 companies I've worked at. So
That's amazing.
Yeah.
Great. Awesome. Thank you.